Hi, ladies and gentlemen. A very good and pleasant evening to everyone. I'm Ms. Lakshmi Balu, host for today's program. First of all, I would like to welcome each and every of you to this educational fair program, and the title for today is a sneak peek into electrical and electronic engineering. We have our guest speaker with us today. A warm welcome to our presenter, APIR Dr. Nurul Azlina binti Nordin, Professor Madya in Department of Electrical Engineering, College of Engineering, University Malaysia Pahang. With pleasure, I would like to introduce a little about our guest speaker to you all. She is Assistant Vice Chancellor, Industry and Community Collaboration, UMP since 2021. She did bachelor and master degree in USM and PhD in the University of Edinburgh, UK. She also contributed as international journals and conference reviewer, external examiner, and also in STEM educational as well. She also winner of 2018 Anugerah Industry and Community UMP, winner of 2017 Anugerah Academic University UMP, APC 2015. Before our program begin, I have announcement for audience. If you have any questions, any clarification, or any ideas to share with us during our speaker presenting, you are most welcome to post in comment section. Thank you for your attention. Without further ado, I would like to hand over this season to Dr. Nurul Azlina to proceed as sharing. The floor is yours now, Doctor.
Hi, thank you very much, Cikgu Cita Lakshmi. Thank you.
Yeah, that's my pleasure.
It is a very nice introduction. I hope my journey towards becoming who I am today would inspire students in school today to take up and pick up STEM. STEM has been part of my career since returning from my study leave back in 2013. Whereby since then I've involved in a couple of activities that involve STEM. So and when we STEM, that the you need to leave out the arts or any other subjects are not STEM related. What we are trying to promote to you today is actually to consider STEM as part of your career or as part of something you would like to venture in future later on. What STEM does offer is that it gives you a wider opportunity. And like me myself, I like to play musical instruments. I like to do arts-related subjects. That does not mean that it does not hinder my passion to delve very much into STEM as well. So in whatever career path or in whatever subjects that you are planning to take up later in your tertiary study especially, do your best and try to achieve the most. And I would really thank Persatuan Guru STEM Malaysia for giving me this opportunity to share a little bit about electrical and electronics engineering being one of the branches of STEM. So I believe everyone here is very much familiar with the word STEM, which stands for the word science, technology, engineering, and mathematics. I would like to bring or have to do a little sneak peek into the engineering part, specifically electrical and electronics engineering. So I would like to share my screen if that is okay, Cikgu.
Yeah, okay, Doctor.
Thank you very much.
Yeah.
Okay. So, well, before I start, I would just like to get some feedback, perhaps from Cikgu and also from the audience. Okay, please listen to this audio. Okay. May I get a little feedback from Cikgu? Do you hear? I'm going to play again this video. Okay, Cikgu. If I can get a little bit feedback from you, what words did you
I
hear
heard
just
AI, something like that, Doctor. Is it? AI. Doctor?
Sorry?
I heard AI, something like that, Doctor. Doctor, are you there? Okay, little announcement for audience. Please wait for our doctor. Maybe having internet connection problem. Yeah. Okay. Okay, Doctor. Now you're audible.
Okay, good. Can you hear my voice, Cikgu?
Yeah, yeah.
Okay.
Now only
Okay,
can.
good.
Okay, Doctor.
Okay, all right. Sorry, I'm sorry for the disruption just now. So I would like to replay this again. Is the video sounds okay? Do you heard Laurel or do you heard Yanni?
The audio is not so clear, I think, Doctor. I
I
heard
see.
like
Okay.
AI something.
Okay, okay, I see. Okay, then it is okay. I think there must be some lagging with the internet connection and so
Ah,
on.
yes.
Later, what you can do is that for students or for cikgu, if you would like to hear again this audio clip, you can just go to Google and type in Laurel versus Yanni. So this is one audio that is playing one sound, but eventually us as human, there we are being divided into two groups. One group would hear the audio clip just now as Laurel, and the other group would hear the audio clip as Yanni. Okay, I myself, I hear this clip as Laurel, whereas my son just now, who happens to be around, heard this and he heard the word Yanni. So how can a same audio being played at the same time but being translated or being heard differently? Okay. So there is I think back in 2017 or something like that, this has been viral around, and there is a debate and there is a survey that has been done where they make like a statistic saying that women tend to hear Yanni rather than Laurel, whereby younger listeners tend to listen Laurel compared to Yanni. So that distribution, whether it's male, female versus female, young versus old, has not been has been done in a small sampling. Well, there might be true and there might be some discrepancies. So what I would like to highlight here is that let's have a look on how do our ear translate or receive information. So when someone speak or when there is an audio or there is sound wave being propagated, our ear will pick up the voice ataupun will pick up the sound. And what happen is that as it go through the ear canal, it passes through our auditory bones and also going through cochlea and so on. So these processes are prone to frequency. Okay, meaning to say that there, as our human population is being divided into a couple of categories, but in this case, there is one set of population would have different frequency changes. I mean, their ear is prone to certain frequency changes and so on. Hence, the same audio would be translated differently. So um, this is something related to what you will ataupun what you go through in physics, these subjects physics, whereby we learn about frequencies and how waves are being propagated, and what is the main use of our earlobe, whereby it can capture the sounds, and it helps to enhance the sound so that the sound can go through the ear tunnel and so on. So what is happening with our Yanni and Laurel is that the audio recording that has been played, if we were to zoom in, there is a device, by the way, that can zoom in these signals, and we can see that even though the spelling here and also the profile, okay, the syllable, when I mention the word Laurel, if you see my mouth here and Yanni, there isn't much similarities. Okay, there is a technique that is being widely used by deaf people whereby they do lip reading, and from lips they can sort of like identify the words that have been said by by persons and so on. So that is why even though there are some deaf people, even though they are deaf, they can sort of understand what people are saying based on the movement of the lips. But in this case, if I were to say the word laurel and the word Yeni, if you were to see from my mouth, we are not having the same profile. But signal-wise, when we zoom in and when we look into the signal, what we can see here, the profile is quite same. Okay, when we mention the word laurel, as it goes here, the pitch gets high. Then if you look here, the pitch here even though it is much lower compared to laurel, but the profile that we are having here is having quite high in the center, okay, and it is like low in the beginning and as well in the ending. So laurel tend to be in a lower frequency range, whereby Yeni tend to be in high frequency range. So for those who listen Yeni, what it means is that the way the ear system is working well in high frequency. Okay, hence there are situations whereby certain sounds, certain sounds that can be heard by young or old generation based on how the ear is processed. Okay. So what I would like to highlight here is that the process that we send information when we speak, we have the sound wave and so on, and as our ear is picking up the sound wave and as our ear is processing and so on, had inspired human to replicate this process. Okay, and that process, if you can have a look on a device that everyone is having today, like this smartphone, has been utilized and has been improvised. The technology itself has been has inspired quite a number of innovations, especially in the communication system. So the way when we speak through our phone, we speak in a frequency that can be heard by human, but as it goes through our phone, it has been the frequency had been increased. We call this as uplifting the frequency. And later on, when this signal is being processed electronically, and before it is being sent out to the antenna, which is the main unit that is responsible to convert that electronic signals to electromagnetic signals. Only by having electromagnetic signals, then we can send the signal to the base station before the signal is being sent to another base station, so that another user, the caller, the one that we call, who should receive the call, could listen to our voice. Okay, so that is some introduction into what is happening with the normal science and so on that inspired some of the devices and some of the findings that we have in electrical and electronics engineering. Okay, so roughly STEM just now, that E stands for engineering. So when we talk about engineering, in general, it can be divided into 4 main clusters. Okay, so if we were to look here, Cikgu, can you guess what does this M stands for, Cikgu?
Manufacturing.
Okay, this M, manufacturing is a sub-branch of this unit. So this M, if normally when we have gear and when we have spanner and so on, we normally tag this into mechanical. So
Mechanical, okay, ma'am.
Manufacturing, yeah, it is indeed one subchapter of the mechanical, because normally manufacturing would require mechanization of system and so on, and it involves as well electronics and so on. Okay? So yeah, correct, Cikgu, this is mechanical. How about this one, Cikgu? There is this one lightning.
Something, doctor.
Yeah, correct. This is electrical, yeah. Okay, and how about this one, Cikgu?
Chemical.
Correct. Chemical. And the last one. Okay, this
Last one.
This involves drawing and building buildings.
Construction.
Correct.
Okay.
It has to do with constructions. So normally we term this as civil
Okay,
engineering.
civil. Okay, ma'am. Okay.
Okay. So in general, the clusters, the normal clusters, and also the Engineering Accreditation Council, who is being positioned under these boards of engineers Malaysia, we sort of like describe ataupun we divide the disciplines of engineering into four main clusters. We have mechanical, we have electrical, we have chemical, and also we have civil engineering. Okay, and of course, in mechanical, there is also sub-branches such as the mechatronics, such as the manufacturing. In electrical, we have sub-branches such as telecommunication, like the one when I explained what inspire our communication engineering, such as the way we speak and the way our ear translate the signal and so on. That is telecommunication. So we have telecommunication engineering, we have electronics engineering, the one who is in charge of making IC devices, making computers and so on. Okay, and there is another one is chemical engineering, and the last one is civil engineering. Okay, let's have a look in detail in the branches that are available in electrical engineering. Now, normally when you look into UPU form ataupun when you look into universities, when they sort of like any promotion ataupun any brochures that they send out to school, we normally term this as E&E. E&E, when people say the word E&E, it will denote electrical and electronics engineering. Okay, so under E&E, there is also an sub-branches that can be divided ataupun that can be clustered into power engineering, microelectronics, telecommunication engineering, as well as computer engineering. Okay, for power engineering, normally it involves from power generation. Okay, kalau macam if we were to drive from Pahang back to go to my hometown in Penang, so we normally go across a very huge apa nama tu, empangan, what do we call it, a dam, very huge dam, in which normally we use a dam to convert energy into electrical energy. So this electrical energy is being placed into one station. Then from that station, it is being distributed throughout Malaysia. If the dam is huge, where it can generate quite a big numbers of numbers of electrical power, then it is being used to distribute throughout Malaysia. So how do we distribute signals? To distribute energy ataupun electrical energy is if you look through your houses and so on, those the electrical grid, the one like a big wire. You can see this a lot as you drive through the highway and so on. So that distribution involves into scaling down the power. Normally, the power that is being required in our houses and so on at a very minimal ataupun at a fraction amount, in which we will do this down converting into a lower energy and so on, so that it is just sufficient enough for the usage of a house. So the one I'm talking here is involve power engineering. Okay, secondly, we have something that involved with electronics ataupun we call this as microelectronics. If you look into your handphones and so on, if you have broken phones, don't just throw it away. Ask permission to your parents. You would like to dismantle for learning purposes. If you dismantle your smartphone ataupun your phone and so on, you will see there is like a small motherboard, the one a board that contains a lot of electronics component, and how the components is being arranged into the board require knowledge in electronics system design. Or then if you can go further, if let's say for example you would like this to design IC. When I mention the word IC, it is not identity card. Yeah, when I mention the word IC, it stands for integrated circuit. Okay, normally if you have like circuits, and if you look into your motherboard, if it is like computer motherboard ataupun a small board that contains quite a number of components such as resistors, capacitors, inductors, you will also see sometimes there are black boxes. Okay, those black boxes can come in rectangular form, it can come in a square form, something similar to the one that I'm showing here. So this is known as IC, integrated circuit. So to design this integrated circuit require knowledge and also require competencies in electronics design and so on. Okay, another one more that is very much influencing our life today is telecommunication engineering. So in the beginning of the session just now, I sort of like explained a bit on how our human ear works and how do we communicate between one person and another person. So basically, vocal ataupun verbal communication will involve one person sending out sound wave, and the other one person who is listening would capture the sound wave and translate ataupun and have to translate that into information that can be understood. So for telecommunication engineering, that goes the same way as well. Now, when we talk about telecommunication engineering, it covers quite a variety of communication. It can cover between human to human communication. Say, for example, just now using phone. It can also covers the way like we watch television, broadcasting. Okay, that is also one part of communication. Cikgu, are you familiar with this shape of antenna? Something like dish. Do you see this around in your house or something like that?
Radiation something, doctor?
Yeah, correct. It does involve with radiation. Do you have astro in your house, Cikgu?
Yes, doctor.
Okay. So when you want to subscribe to Astro service, so what do we normally do is that we will call the Astro line and so on. So what will the Astro contractor do? They will come and install the antenna, isn't it? Something shaped like a dish, like a kuali.
Yes.
Okay. So normally they will install in our house. So now what it does is that basically that kuali, in electronics, in electrical electronics domain, normally we call this as dish antenna ataupun parabolic antenna. So parabolic antenna ni is a scientific ataupun is a normal term. So dish antenna ni is like a communication term. As the dish tu dia resemble something shapes like a pinggan ataupun like a kuali. So normally that is this is a term that is being widely used as a dish antenna that is being installed. So what is it does is that that dish antenna it operates something like your earlobe. Okay, if you can recall just now, I mentioned that when we talk, normally we will generate our voice is being ataupun we are generating sound wave. Okay, that sound wave propagates into the air, and as I listen to the sound wave, what happens is that our earlobe helps to capture the signal. Okay, there is a reason why our ear is shaped like this. Okay, not like any other shape. Because if you look through shape like this, it will help to bounce the signal so that signal is reflecting into a certain degree ataupun angle and can be channeled into our ear tunnel. Okay. So that goes the same thing as the dish astro antenna. So what it does is that when shape, if you look into the shape, it is a little bit like parabolic, semi-hemispherical shape. Okay. As the signal being sent into this dish, it reflect to one to another so that the final signal is being sent into this center part of the antenna. Okay. Kalau if you were to go and look into your astro dish hari ni, now if you were to look into your astro dish, you will see that the main construction of the astro dish dia ada two parts. The first one is the parabolic ataupun the dish, the one that I'm showing here. And the second part is this part. We call this as a horn ataupun horn ni HORN, horn, ataupun as the receptor of the central part. So what it does is that as the signal is being received, it will being bounced from one point to another point within the dish area, and later there is a precise calculation so that that bouncing and so on will later end into this horn sector, so that the horn sector will capture all the signal. Okay, something similar to your earlobe just now. The earlobe, okay, will capture the sound wave and later on will pinpoint into your ear tunnel so that all the information can be sent via the ear tunnel to the cochlea. Okay. In this case, all the signal is being captured by the dish and being sent to this horn. Now, the horn here, now normally when we draw and so on, they simplify things. But if we were to go near to the antenna, you will see that there are wires that is connecting this unit, the horn unit, back into the central processing unit. Okay, that central processing unit is in charge to translate the signal into signal that is being understood by human. Okay, kalau in our case for astro reception and so on, it's being down convert. Okay. High frequency, they send signal via high frequency range and will be down converted into a lower range so that it can be processed and also generate sounds that can be heard and translated by human, as well as videos. Okay, videos in terms of signals that can be displayed via your television. Okay, so those kind of domain and so on, we normally call this as telecommunication engineering. And the other subclusters ataupun sub-branches in electrical electronics engineering is computer engineering. So computer engineering is very interesting, and if you have some time, you can have a look in the early years back in 1939 something, Alan Turing, when he start to introduce computers. The computers back then is not the same size as what we have today. Okay, kalau today, if you can see our computers now, if you can see, this is my laptop that I am using here, is around the size of an A4 paper, but of course is much thicker compared to A4 paper. But in the early days, it is as huge as half of a room. Okay, because the mechanization and also the system that is being required in order to compute. Okay, when we say the word computer means, what does it do? It compute. To compute, it requires a huge area to implement. Tapi as we go into time, as we move into time and so on, people do a number of researchers, and from that researchers find out a way on how to reduce the size. So basically, when people start to come ataupun start to invent transistors, okay, transistors. So there are quite a number of things, switches that can be done with transistors, and the smaller the transistor, the smaller the electrical system that you can have. So this kind of thing, dia memang ada influence ataupun give some apa nama tu, what we call this as invention that inspire electrical electronics engineering products ataupun products ataupun findings. Okay, so when we talk about electronics engineering, okay, a sub branch of that electrical electronics engineering just now, normally people ataupun me myself, before I enter into this area, I would assume that an engineer who's in charge in electronic system would be someone who would have to design these chips. This is the IC. If you can have a look onto my slide here, this is IC. We can have like apa nama tu, the placement of these ICs, as well as if you can see the small components here, you can see there are LEDs, there are resistors, there are capacitors, transistors, and so on. So but of course things are getting smaller, but human are not as small as the one that I am showing here. There are few software ataupun few tools that we can use in order to simulate ataupun to implement the electrical system design. Okay, this is something that I would like to highlight. I remember that upon graduating ataupun upon finishing my undergraduate years, after finishing my sixth semester, what happened is that my television is broken. So my father, he mentioned to me at that time for me to fix the television. Unfortunately, I don't have the skill to fix this television. I might be able to explain how television works and so on, but I do not have the skill to dismantle the TV and to do the corrections of whatever broken at the time. So this is a normal scenario. So when you mention to people that you are doing ataupun you are learning electrical electronics engineering, people would assume you would have you are currently studying something to do with your distribution board. something to do with this electrical distribution board. You normally see this in your ataupun at your front door, ataupun normally we normally install this in the front door near to the apa nama tu electric wires and so on. Okay. What other colleagues ataupun other engineers think I do. Okay, this one normally people at the same in the same area would normally understand this. Normally what we do is we troubleshoot circuits. So if you like to watch CSI, CSI crime scene investigation kan, when there is a crime, so how do the inspectors ataupun how do the investigators do the work is by investigating ataupun trying to troubleshoot, trying to find who is the culprit that done those kind of criminals and so on. So that was the same thing when we have broken electronic circuits ataupun broken equipments. So what do? We normally try to investigate what went wrong and try to fix it. So how do we know? Kalau human, say for example, if you are sick pun, when we go and see a doctor, what the doctor normally do, dia akan diagnose. He would ask a couple of questions in order to get some insight into what is wrong with you, so that he can prescribe you the right medicine. So in this case, when we want to troubleshoot circuits, normally we will have something here, which is the multimeter and so on, to try to get the reading ataupun trying to get the values that is being generated by these ICs, and try to see whether that is correct ataupun there is incorrect signals and so on. So what my mom thinks I was learning at that time, ataupun what my mom thinks I am doing when I mention the word electrical engineering, is normally you should be able to try to fix your lights, try to fix your television, try to fix your electrical appliances. Okay, but what my friends think I do normally when I during semester break and so on, I get in touch with my classmates in my secondary school and so on. Electrical electronics is quite a challenging course as well, because it requires quite a number of things to understand, for you to understand, in order for you to be able to design, and in order for you to be able to make inventions and so on. So what I think I do, this is something that I wouldn't run away from, because there will be a lot of electrical diagrams that you need to digest, you need to try to understand, and that you need to design and so on. But don't worry, because normally there will be like 3 to 4 years for you to build up these skills. Of course, if you were to look it now and you want to learn it looks quite complicated, but you will have like 4 years to learn about this and to master about things and so on. Well, what I really do at this stage, I like Google and so on. Now, when we mention Google, there are quite a number of things. So Google is our new library. Okay, you might not be able to find correct answers sometimes, because you can see there are a lot of information available on Google, but it requires you to be able to filter to find the right answer for your questions. Okay, but nevertheless, compared to the olden days and what we are having now today, Google can give you information, and with the right filtering and with the right knowledge, you can filter the right answers and you can get the answers and also the information. I always encourage my students, whether it's at the university stage ataupun at the secondary stage and so on, when I do engagement with school children, to keep asking questions if you don't know. Okay, but when you want to ask questions, make sure the questions is something that you can't Google. Okay, contohnya, if I were to teach you something to do with electrical circuits ataupun with electrical drawing, something similar that I'm having here, if you would like to know what is the functions of transistor, what does a transistor do, you can easily Google this. Okay, when you want to ask questions and so on, if you go a bit further and try to ask questions that you can't Google, say for example, why do we need to have transistors in radio? Okay, those kind of things would give you a better response in a way, and would create ataupun would create a scenario whereby whether your teachers ataupun your lecturers can have an interactions. Okay, because when you ask the word about how ataupun about why, normally you have gone through the first layer of trying to understand things as such, what is. Okay, so for example, when I mentioned the word just now like parabolic dish, okay, you can try to Google and see around what is parabolic dish. So parabolic dish is a kind of antenna and so on. And then later on, you may want to know a little bit further. For example, where do we use this parabolic dish? Those kind of thing, if you were to ask your teachers ataupun if you were to ask the instructor and so on, that would give a better chance to create a more meaningful interactions. Okay, but having said that, say for example, if you don't have Google and say you don't know a thing here or there, don't be shy. Always encourage yourself to ask questions. There is no such thing as stupid questions, because sometimes your questions, okay, when you ask, you are not only helping yourself but also you are helping others who happens to be wanting to know the answers as well. Okay, so when during my childhood time, I always like to play this game. So normally what we will do at that time, we normally take the milk can ataupun tin, the one that has been finished. We normally recycle this, we wash this very carefully, and later we will take apa nama tu, wire ataupun sometimes we would the thread ataupun benang ataupun simply rope, small rope to connect between these two tin ataupun two cans. So interestingly, if we make this at a proper tegang, what do we call tegang, at a proper distance, and the cable ataupun the thread ataupun the tali ataupun rope just now is at a good ataupun string at a good place, at a good tension. The right word is tension, tegang. Kalau dalam bahasa Melayu we call this as tegang. In English we call this the right tension. You can listen to the other person ataupun to the person on the end when they speak via this tin. You can listen to the voice and you can capture the information. It really works like a landline telephone. Okay. But if you do not have the right tension, tegang, the right tension for this rope ataupun this string, you will see that when the other person speaks, you wouldn't be able to listen. Okay. So that situation during my childhood time playing this, for some reason inspired me to dig a little bit more about this, and the end during my PhD I did design an antenna for smartphone. Well, it might not work something similar with wired communication, as antenna means you are trying to do ataupun trying to equip devices, wireless devices. Wireless devices means two device that are able to communicate between one to another without wire. Okay, something like your smartphone, something like your tablet, and so on. So the scenario that I mentioned just now, why we need the right tension, that is not rocket science. You can have a look and try to look into your physics. If you look into physics subject, you will see that if it is at the right tension, it is able to vibrate. Okay. As you can see, sound vibrations and so on. As the person here speaks via this tin, the voice will vibrate this string, and that vibration, okay, when it is being when it reach to the other end, and as you place your ear there, that vibration will generate the right frequency that your ear can listen to. Okay. Tapi kalau if it is not the tension is not at the right place, the kendur ataupun it is not tegang really well, the vibration cannot take place. So when the vibration when the as you speak, you have signals. That signal couldn't influence ataupun couldn't vibrate the string. Hence, the other person at the end couldn't listen to the sound. Okay. So that is how telephone works. Okay, so this is where last time during ataupun today pun ada in my house. In fact, I have one wired phone. So what happened is that as you speak via your phone, okay, that is it does not vibrate. So in this case, even though there is wire here, this wire does not vibrate. Okay, what happened is that your telephone has a unit that could translate your voice into electrical signals. So that electrical signals is the one that go through the wires here. Okay, so even though it is being connected using wire and so on, the operating mechanism is not similar to the one that we are having here. Okay, because our signals is being translated into electronics, into electrical signals, which later go through the wires. Right. Now, surprisingly, ataupun maybe not surprised to some of you guys, the vibration here, even though it is having wire ataupun string ataupun tali here, the concept that we are having here is something similar to your smartphone, okay, to your handphone, to your wireless phone, okay, because of a unit that we call antenna. Okay, remember just now when I mentioned the antenna can translate the electrical signals that is being generated in your phone. From your voice, it is being converted into electrical signals, and the electrical signals via the RF and antenna system is being converted into electromagnetic signals. That electromagnetic signals is being radiated through the air. Okay, that radiations and so on, dia ada involved frequency, and that frequency is something similar with this vibration here. Okay, because vibration in the end of the day, it will generate frequency. Whether your ear can listen or not to the frequency, that is something that you, when we playing this one, that is something that we need to design carefully. You need to make sure that the string is being connected betul-betul to the tin. Okay, so if you were to make a hole, kalau you make a hole and you put your string inside the hole and you make a tie at the end, kalau dia does not being tied nicely, you will come into a situation whereby the string does not vibrate really well. Okay, itu pun satu. So there were times that instead of we drill a hole and tie a knot in order to connect the tin to the string, we actually take a sellotape and place that sellotape, stick it on the string, and so that the string is sticking into the tin. Okay. Then doing that, the vibration of, as you speak through the tin, the vibration of the tin can be translated into the string. So those kind of things, you can, it is a child play. I was playing this one when I was like standard 1 to 3, trying to communicate with my sisters at the end of the corner and so on, trying to play around with my cousins and so on. You can play this, and you can also look into the science behind this. So hopefully, as you play whatever games that you are playing around, try to go a little bit further and look into the science behind it. That was the same with computers games and so on. Okay, I recently I would like to thank MDEC and also our industry partners such as Motorola and so on. They children, we teach children on how to code. Okay, so if you play games, okay, playing Roblox like what my kids are doing back here, they are playing Roblox with their computer over there. While playing the game, take note on how the player move. Take note on as you press your keyboard, moving up, moving down, moving left, moving right. As you punch into your keyboard, you will see that movement is being translated to the icon that is being. So when there is subjects such as programming, kalau in sekolah rendah there is subject like TMT whereby you learn Scratch. Kalau in sekolah menengah you learn in your ASK like Python, ataupun you learn in your SK such as Java programming and so on. When there are opportunities that you can play around with programming, try to create game, try to recreate the game that you like, ataupun recreate the game that interests you the most. You will and look into the science behind that. Of course, kalau macam itu, it is science. Kalau macam in this case, there are techniques like programming techniques, coding techniques that you can apply. So in our daily life, there are very much ataupun there are a lot of STEMs related things that could inspire ataupun trigger you to think a little bit further. I hope that would inspire you to keep exploring and trying to understand on how things work and so on. Okay, so this is an example of a smartphone. Kalau macam tadi tu, a wire phone, normally it involve wires in order to bring the electrical signals tadi. Kalau in wireless phone, normally what we have here, your microphone will, from your voice, the microphone will translate into electrical signals and so on. And as you listen, you will hear via speakers. Tapi what is not visible here is an antenna ataupun RF system that would convert your signal just now into electromagnetic wave. Only having electromagnetic wave that would enable you to use the communication engineering concept just now, like translate that signals over base terminal stations so that the base terminal station can later on transfer the signal to the recipient. Okay, kalau recipient tu happens to be in Malaysia ataupun whether it is abroad, the conversion time and so on tu kan dia berlaku at a very short time. So if you were to call your friend, say you have a friend in the States, even though it's like 12 hours distance, but the communication and also the signal is moving very fast, you would hear ataupun as you speak to your friend kan, you would hear as though your friend is just nearby. Okay, because of the communication ataupun because of the because of the electromagnetic signals that is moving in a very fast rate and so on. Okay, so this is a bit that I mentioned just now. When we talk about radio propagation, tadi cikgu ada sebut the word radiation. So radiation ni dia ada involve a propagation concept as well. So when we talk to microphone ataupun to your handphone punya microphone, that is being translated into signals and so on, and then that signals is being transmitted into a broadcasting antenna. So here we call this as broadcasting antenna. You will always see this if you were to drive along the highways ataupun in your hometown, there must be at least one of these transmitting antenna. Now, the writer that we normally call this is BTS, okay, not the Korean K-pop music group. So BTS here stands for base terminal stations. Okay. Normally, if you are residing ataupun if your house is nearby these base terminal stations, you will see that your senior recipient and so on, semuanya is like good. Normally tak akan terganggu lah, tak akan terkacau lah. Okay. Tapi kalau if you were being placed in a quite a rural area where you are quite far from this base terminal station, sometimes you would come across situation such as your call is dropped, something like that lah. Tengah-tengah bercakap tiba-tiba hilang. Tapi like me myself just now before ataupun in the beginning of the session, I have trouble with my connection to the Wi-Fi. So what happened is that I am using Unify, but I have quite a number of devices being connected at one time. Okay, I have my kids playing the computer game, online computer game. I have me myself is being connected to the telephone, as well as my laptop now is being connected to the Wi-Fi. So sometimes when you have too many devices connected at one unit, there can be also call drop and also situations like I'm having just now. Okay. So that is also something related to communication engineering, which is also another subsections under electrical engineering. Okay, so this is basically radio engineering, something similar to the one that I mentioned just now. Okay, and then we have around 15 minutes left before end of this talk, cikgu. I would like to explain a bit lah. Say for example, if you would like to become an engineer, what is the available route? Okay, normally if you are in your primary school, one of the exams that we have is UPSR, but I'm not so sure. I'm not sure of you. I have my son, my eldest son, should take UPSR last year, but it has been demolished kan, dah tak ada UPSR. So basically from sekolah rendah ni, you will go to secondary school, and in secondary school there is during my time we call this SPMR, but nowadays we call it as PT3. So PT3 ni, after PT3 you will take SPM. Okay, some of you guys might be in MRSM and so on. You may have exams such as CGSE and so on. So that is also another equivalent exam. It can also be like O level. Kalau if you are doing ataupun if you are taking UK system evaluation, there is this O level. So SPM is equivalent to O level. What you can do after SP is that you can take one of these branches. You can go to matriculations, or you can take A level, or you can take STPM, or you can take diploma. So when you take diploma, normally diploma ni it is not general. It is being the course offered are specific into certain domain. So if after SPM you already know, for example, you want to become an electrical ataupun electronics engineer, considering to take diploma is one of option that you have. Kalau say for example after SPM, like me last time, after SPM I sort of like I sort of like don't know yet which career path that I would like to go through. So if you are in dilemma ataupun if you need some time in order to delve ataupun to find what is the right course for you, you can always take this route, taking STPM, or you can take matriculation. So if you take matriculation, you have around 9 months, okay, to further explore advanced level of courses ataupun of exam like STPM and so on. You will learn a little bit in detail on physics, chemistry, matriculation, matrix physics, matrix chemistry, and also matrix biology and so on. Dia ada advanced ataupun dia ada areas yang dia go further a bit from your SPM content. So by delving into this area, maybe you can have sort of like ideas ataupun you can soul searching, find what suits you the best. So in my last time, I am very much into physics. So after SPM, one of the things that I would like to continue ataupun to do in my tertiary studies at that time when I finish my SPM is to take physics. So kalau physics ni dia ada area macam quantum physics lah, dia ada area macam applied physics and so on. But as I did matriculation for 9 months, as I did my matriculations, I delved into a couple of programs and also look further into the topics. And dekat physics ni ada topics electrical ataupun topik electronics. And eventually, I feel like I would like to further more into this electronics area. Hence, I choose the option of taking electronics engineering. So what I thought, what I mentioned just now is basically bachelor degree. So after doing this, taking your diploma, SPM, A level ataupun matriculation, you have the options to continue your bachelor degree. And normally after bachelor degree, with bachelor degree in electrical and electronics engineering, you are entitled to work as an engineer. Normally with these certificates, you can use your Bachelor of Electrical Electronics Engineering to apply for engineering posts. Okay, whether it is in government ataupun private sectors, normally in universities that is being accredited. This is quite important as well. When you want to choose university, make sure the university that you choose is having ataupun is offering accredited courses. Okay, accredited ni maksudnya there is a body that is in charge to evaluate the course. So for engineering courses in Malaysia, we have Board of Engineers Malaysia. Via this subunit, we call this as Engineering Accreditation Council, who would regularly inspect. Okay, I am teaching electrical electronics engineering. So every 2 years ataupun every year, we have to compile report. We have to submit reports to this council so that they can evaluate. And Alhamdulillah, UMP is one of the accredited institutions that offers these electrical electronics engineering courses. So for an institution to get accredited, there are quite a number of things that we need to do. For example, we need to make sure that we can provide lab facilities, laboratory facilities. We need to make sure that the content ataupun the curriculum that we are offering to you is relevant to today's industry requirement. Okay. For example, just now when you see people kan, the people on IC tadi kan, dia macam sort of like taking up the IC and so on. So that is something related to microelectronics engineering. We have to make sure that the content of microelectronics engineering, the courses that offer to our undergraduate students meet the requirement of industry. Okay, Like for example, relevant industries such as Intel, okay, when they want to hire, there are certain skill set that they are looking into. For example, the student must be able to know on how to do coding. The student must be able to know on how to design IC. So those kind of things we need to make sure that is available in our courses. Okay, once you finish your bachelor degree, you can work as an engineer to pursue path, or you can choose to further your study. Okay, further your study tu means you will go into learning a little bit further from what you have learned from your bachelor degree. And nanti daripada situ you can continue later on kalau you would like ataupun you have the passion to do research and you would like to further your study, of course you can go up until PhD level and so on. So this is a career pathway in order to become an electrical or electronics engineer. And these are some of the skill sets that is required lah, skill set dia ada banyak kat sini, are required for engineering ataupun for engineering courses atau for you to become an engineer. You need to have the right ataupun your engineering knowledge must be good. Okay, secondly, you need to be able to solve problems. As I mentioned just now, macam kita tengok CSI, macam you want to do troubleshooting of circuits and so on tu, you need to have that analytical skills lah. Okay, here under PO2 ni means you are not ataupun you don't easily give up. Okay, that is important. Sometimes simple project pun sometimes we face into trouble such as circuits are not working and so on. You must be strong enough to continue to finish and so on. Yang tu semangat yang ataupun those kind of attitude that we look, okay, when you want to become an engineer. Okay, and then you must be able to ataupun to design solution, and you must have that investigative mindset. Okay, contohnya kalau barang rosak ataupun if there is any project tak boleh jadi, you don't just simply say tak boleh jadi abang beli baru. We don't want those kind of thing. Kalau boleh, you want to look kenapa dia rosak, how can I fix it, if there is anything that you can do in order to make it better. So those are engineer mindsets that you need to cultivate. Okay, and that goes the same thing on modern tool usage ni, macam mana if you can use softwares ataupun current softwares that are applicable to the course and so on. This goes up until project management lah, which means that you need to be able to be disciplined enough. Kalau when we talk about project management, it means that you need to be disciplined enough, okay, in order to make sure that you are competent and people would like to hire you as an engineer. Okay, I think okay, before we end, one more slide, Cikgu, boleh sikit, just would like to touch a bit on this, we call this as disruptive technologies. Okay, kalau tengok dekat sini, COVID-19, okay, what is the most thing ataupun interestingly, COVID-19 ni people during our first lockdown, second lockdown, kalau tengok dekat sini kan, people start to order food, to order things via Food Panda, sending things via Food Panda and so on. So how do people, kalau dulu lah kan, sometimes I am quite skeptical kalau kita nak pesan barang to strangers. Say for example, we are asking strangers to purchase us food. Okay, macam mana nak beritahu kat dia what kind of do we need? How can we make sure that he purchase, for example, we like nasi ayam kan? How can we know that that person purchase nasi ayam at the right kedai yang we like, not just simply go into whatever kedai and so on. So kalau tengok dekat sini, GrabFood ataupun Food Panda and so on, they create an apps that is people can download the apps, and from that apps people can place order. Kalau macam abang Food Panda ataupun abang Grab ni pula, they can look into the apps to find jobs ataupun to pick up jobs in order to deliver things and so on. So that apps tu we call this as disruptive. Okay, dia bukan apps tu maksudnya dia merosakkan alam, disrupt, merosakkan atau menghancurkan alam. We call this as disruptive because it change the normal way we do things. Okay, kalau dulu, say for example, I want to purchase McDonald ataupun nasi ayam ke McDonald lah. I must drive to that McDonald ada drive through facilities and so on, tu pun dah bagus kan, dia pun boleh apply dekat yang drive through punya facilities. So make sure that we place that order and so on. So kadang-kadang tengah-tengah nak pergi tu, mula-mula rasa macam nak makan sundae, tapi dah sampai dah queue tu tak nak sundae lah, saya nak beli McFlurry lah. So those kind of changes and so on, semua tu better, senang kalau kita pergi sendiri. Tapi kalau kita tengok sekarang ni with Food Panda application ataupun and so you are able to do so. Say for example, you dah place order and then later on before bayar, I nak change my mind lah, tak nak makan nasi ayam lah, nak tukar nak makan mi goreng. So those kind of thing able to be done ataupun you are able to do it within when you are at home. So that is very much different from what normally we do lah. So those kind of things. So kalau tengok kat sini, disruptive technology ni dia involve a number of things that this said makinnya involve like mobile internet of things, the way you control things and so on via internet, cloud technologies, advanced material, 3D printing. 3D printing pun something yang interesting juga. Kalau dulu say for example I want to create this bottle, okay, I cannot simply just create this bottle macam tu saja. I need to create mold. Mold tu maksudnya acuan. Then from that acuan tu normally acuan buat dengan apa nama tu tanah liat ataupun dan sebagainya. Dia ada certain materials untuk kita nak buat acuan. So when dah ada acuan tu baru kita tuangkan kalau macam ni plastik cair in order untuk dia beku dan dia become something shape like this water bottle. So kalau we are talking about just making this one water bottle, tak possible. Tak ada siapa nak ambil kita nak buat satu water bottle ni sebab proses nak buat mold and so on tu dia very costly. Okay. Tapi bila kita ada 3D printing, okay, your school might have 3D printers and so on, dia allow us to make only one unit. Okay, 3D printing dia boleh, kalau you design this properly, dia boleh buat bentuk yang macam kita ada ni, so that you can create shapes, weird shapes yang susah nak buat dengan mold and so on. So kalau tengok macam tadi kan, setengah pelajar dekat rumah dia pun ada 3D printing, 3D printer, dekat sekolah pun ada 3D printer. So 3D printer has become cheap today. Everybody has the access to 3D printers. So bila you ada 3D printers tu, you can almost create ataupun design ataupun print 3D design. So itu pun mengubah ataupun change the things that we normally do, how we do things lah. Okay. So that being said, cikgu, that's the end of my talk for today. If there is any questions and so on, I am more than happy to answer.
Okay, such a great sharing, Doctor. I myself learned a lot, new useful information as I revised back my physics classes during secondary education because engineering more related with physics, right? Okay, thank you, Doctor, for delivering useful information to our audience today. All right, ladies and gentlemen, now we are come to question and answer season. As Doctor suggests just now, encourage yourself to ask relatable questions. Our doctor here to share knowledge with us today. You may post your question in comment section if get any. Okay, seems there's no question. I'm sure our audience clearly get information from the presentation today. If you want to study engineering, you may choose UMP. Let's explore more in STEM education together. Finally, here we come to end of our program. A kind reminder to all the audience, please kindly fill up the form using the link given with correct information to get your credits in SPL KPM. We would like to thank again to our presenter today for the informative and interesting sharing and our audience as well to lend your ears to us. Also actively participate in all our PGSM programs. Hopefully the presentation will be beneficial for everybody. Thank you for joining with us and keep in touch with PGSM for more beneficial programs in future. Stay home, stay safe, stay happy. Good night, everyone. Bye.